Hello students, today we will be discussing the questions of NCERT of chapter Force and Laws of Motion. So in this topic we will be discussing some numerical problems which are given in the NCERT exercise. So starting with it. So our first question is a truck starts from rest and rolls down a hill with a constant acceleration. If it travels a distance of 400 meter in 20 seconds, find its acceleration and force acting if its mass is 7 tons. Now, in this question, it is said that a truck is starting from the rest and it is moving with a constant acceleration a distance of 400 meter in 20 seconds. Now, the first line only suggests that starting from rest, it implies that the initial velocity, that is u, is 0 meter per second. As it is said that it is a traveling distance 400 meter. So S is 400 meter. This distance is covered in t equals to 20 seconds. Now we want acceleration. So acceleration can be calculated by using the second equation of motion, that is S equal to ut plus half at square. Now we know about S, that is 400. Ut will become 0 as u itself is a 0. What remains is half. A has to be calculated while t is given as 20. So it will be 20 square. So on evaluating the value of A, we will be getting it as 400 over 200. That is equal to 2 meter per second square. So this is the acceleration with which a train is moving. Now we want force that was acting on the truck. Now it is given, we know that F is equal to m into A. It is given to us that m is equal to 7 tons. And we know that 1 ton is equal to 1000 kg. It means the mass is 7 into 1000. That is 7000 kg. Now F will be 7000 into A, that is 2. So force acting is 14,000 Newton. Now let us discuss another question. A stone of 1 kg is thrown with a velocity of 20 meter per second across the frozen lake and comes to rest after traveling a distance of 50 meter. Now In this question, we have to evaluate the force of friction, means the force which opposes the motion. Now, in this question, we are given that the mass of a stone is 1 kg. Then it is said that it is thrown with a velocity of 20 meter per second. It means the initial velocity is 20 meter per second. Then it is said that it finally comes to rest. Finally comes to rest implies that final velocity is 0 meter per second. And it is said that it is traveling a distance of 50 meter. So now we want A to evaluate the force by using the third equation, that is V square minus U square is equal to twice of AS. We will be getting minus of 20 square equal to 2 into A, that has to be calculated, into 50. So value of A will be minus 400 over 100 is equal to A. So A will be equals to minus 4 meter per second square. Now we know that F is equal to M into A. We know that M is 1 into A, that is minus 4. So force is minus 4 Newton. Here negative sign implies that force is opposing the motion. As the question said that we want to evaluate the force of friction. So itself is self-understood that the force, whatever force will be acting, will be opposing the motion. Still, in any equation, if you are getting force as a negative value, then you should note that, or you should write it, that what does the negative sign implies. Next question. A 8000 kg engine pulls a train of 5 wagons, each of 2000 kg, along a horizontal track. If the engine exerts a force of 40,000 Newton and track offers a friction of 5,000 Newton, then fine, we have to evaluate something in parts in this question. First is the net force, next acceleration of the train, and last the force of wagon 1 on 2. So these three parts we have to do. Starting with the first part, we want the net accelerating force which is acting on the train. So it is said to us that whenever the train is moving, it is having a force of 40,000. F is acting, that is 40,000 Newton, and the other force, which is frictional force, that we can say is minus F, is equal to 5,000 Newton. So we want the net force. Net force will be equals to 40,000 minus 5,000, because this 5,000 is opposing the motion of a train. So the net force is 35,000 Newton, which is acting on the train. Or we can say that 35,000 Newton is an accelerating force, means the force which is contributing in the acceleration of a train. This was our part first. In part 2, it is said that we want the acceleration of a train. We have, in the first part, we have evaluated the net accelerating force. That is, the force providing acceleration is 35,000 Newton. Now we know that F is equal to m into A. And for A, we need F over m. Now we need the net mass of a train. For the net mass of the train, we know that 8,000 kg is a mass of engine itself, plus 5 wagons are there, and the mass of each wagon is 2000 kg. So the total mass of the wagons will be 5 into 2000. That is, the net mass which we are getting is 8,000 plus 10,000. That is, m will be equals to 18,000 kg. This is the net mass of a train including its engine plus wagons. So for the A, that is F equals to F, that is 35,000 over m, that is 18,000. So on solving it, we will be getting 1.944 meter per second square. So this is the acceleration of the train. In last, we want the force of wagon 1 on wagon 2. To evaluate the force of wagon 1 on wagon 2, we first evaluate the mass of all wagons. We want the mass of all wagons. Now it is said that the first wagon is exerting the force. So we will be excluding its mass. So we want mass of all wagons but except the first. So left out wagons will be 4 and each has mass 2000, so into 2000. So the net mass will be 8,000 kg. Now we want acceleration to find the force. So acceleration just now we get that was of train. Now we want of a wagon. So we know that the net force or the accelerating force is 35,000. The force is 35,000 Newton and mass of the all wagons is 10,000 including the whole, because this net accelerating force is exerted on all wagons including that wagon also. So acceleration will be equal to 3.5 meter per second square. Now we have mass as well as acceleration. So F will be equal to m into A. M is 8,000 while acceleration is 3.5. So on multiplying it, we will be getting 28,000 Newton. So that is our net force which is acting on wagon 1 by wagon 1 on wagon 2. So these were the few questions which we discussed of NCERT. Thank you.